Okay, in this video, we were going to discuss Geometry Congruence Standard 7 and 8. In particular, we discussed in class yesterday that part of the standards, besides using the triangle congruence theorems, you also have to be able to explain why they are true. And so basically, we've got a series of questions that we're just going to answer today. Just get them written down, and then we'll have that homework pretty much finished up. So launching right into it, state the angle-side angle theorem. And here it is. Okay, that's the angle-side angle theorem. If you have two triangles, and there are two pairs of congruent angles, congruent corresponding angles, and you also have a pair of included sides that is congruent, then we would know the triangles are overall congruent. I wrote this with some spacing because there is some terminology that we've been using and we've defined it, but I want to make sure that you still remember it. In particular, what does that thing mean? Okay, pretty simple. Congruent means they're the same. Corresponding, what does it mean? Corresponding means that they're in matching positions. And you could have matching positions for angles. You could have matching positions for sides, but they're in matching positions. Now what that means for us, and I'll scroll back up to give you more time to write. If you're watching at home, of course, you can pause the video or rewind it. But just know that you will have more time. But we could take and say here, here, and here. And this is, whoa, didn't mean that to happen. Come on. All right. And you guys just saw me copy and paste this triangle. And so I can grab it over here. And we know that we could do reflections or rotations. And I'm going to grab this piece and flip this down. Okay. Here's the question I would like to note, or rather an observation. This side is on the bottom. In the other triangle, which side corresponds to it? It's, I'm looking at it, that one. In particular, what we're trying to note, it's not about being bottom matching bottom or left matching left. That's when we say matching or when we say corresponding, that's not what we mean. If we were to use the movement to make these shapes match up perfectly, which are the pieces that go on top of each other? That's what corresponding is. If you move it, they fall on top of each other. And so for this particular one, are these two blue pieces corresponding? Well, if they are, we should be able to do some type of a movement. So I could take this piece and do a reflection. And I could grab it and use a rotation. Please notice that this is the piece that just got reflected. Okay? So when we grab it, make sure that you're watching to see where it goes under the rotation. And then we could translate it over and see that's how we had it. Besides having matching or corresponding sides, which we had here, we could also have corresponding angles. Which angle corresponds to this one in the red? Okay, and I'm seeing people in class pointing up at this one and saying that one at the opposite side of the blue. By the way, I love the fact that you use the word opposite, because later on in the year when we're using our trigonometry unit, that's exactly one of the words that we're going to be using in trigonometry in the second semester. So, sweet. Okay, so those are examples of corresponding parts. I'm going to leave these ones up here so that we can look at this as a further example. And I promise you I'd give you more time to write, so pause the video if you need to, but finish writing this one up. All right, so what this theorem does for us in particular, we were discussing the other day that in order to use a definition for matching parts, we need 3 pairs of sides to be the same and 3 pairs of angles to be the same. So that's a total of 6 pairs. This gives us a shortcut, but it can't just be anything. When we're looking at the part, this name tells us what we need and the order we need it in. Please notice that it says angle and angle, so we have to have 2 pairs of congruent angles to use this. Well, come down here. Please remember what I said about the tick arcs. Having 1 matching 1 in the red means those angles are congruent. Well, let's suppose we also have angle matching angle being congruent. These pictures do not work for angle side angle. The name also gives us the order. We must have the side in between the pair of angles. That's actually what this word right here of included means. Included, informally, means it's connected in between. So when we look at these 2 parts, how we've got the 1 arc and the 2 arcs in the red, in order to use angle side angle, it can't be that pair. We would have to have the side in between them. If somehow we knew that those 3 pairs of corresponding parts were the same, we get all the rest of it for free. Having these 3 pieces gives us for free that these sides are the same, and those ones, and this angle. All this stuff in yellow we get for free just by knowing those 3 pairs. Part of our standard is using this to answer questions. That will be a big focus of our work next week. A lot of our work is going to be which one are you using, actually work with it and use it in problems. Our focus right now is not using it, it's explaining why it's true. And that's our next question, and it's the next question on your writing for your notes. How does angle side angle guarantee congruence through rigid motions? Well, I'm going to note that, like we were discussing before, there is a logic, there's a thought process to the explanation. And we're starting off by saying angle side angle gives us something. the thought process we need to work with. Do you remember how we were talking in class the other day that if you have two shapes that are the same, one has to be a copy of the other? That's what we're trying to take advantage of. Angle, side, angle. I want to pause here. I'd like to backtrack to this part in a second, but to help make this more clear for the justification, I would like you guys to create a drawing. So please let me backtrack. I apologize for this getting a little bit out of sequence, but here's what I'd like you to start with. And this is not in the homework part that you're writing down. This is on the blank sheet of paper that I asked you to get. Here's where we're going to start. Draw an angle, side angle triangle that has a 30-degree angle, a 3-inch side, and a 70-degree angle. I'll pause the video and let you try it out. Okay, as people are working, I'm going to put in my tools. I'm going to put down the ruler so I can measure my 3-inch side. Where is the ruler? It's probably up at the top of the page. I'll have to bring it down, I think. Yeah. Okay, bring that down. And bring it down more. And then I will also need a protractor. So I'll insert the protractor. And I'm going to have to bring that down now. And I want to shrink this a little bit. Whoa, a little bit. That's too much. Okay, so starting off, when you are doing these types of pieces, I would recommend the piece in the middle should be your first step. Start there. Because after you've drawn the piece in the middle, you can just attach the other things to the left and the right hand sides. Of course, this isn't the only way to draw it, but it's a very easy way to make sure that you get it done. So to start off, here is my 3-inch side. 1, 2, 3. Okay, and I can drag that down and say, whoa, drag this away. And this is 3 inches. Next, I need to attach a 30-degree angle to the end. And remembering how to use the protractor, if you look down here, where you should have a hole, you'd place the hole at the end where you're going to put the vertex. And then always start your angles on the side with 0. A lot of students mistakenly think that you always use the outside set of numbers. That's not the case. You always start at 0. And in this instance, 0 is on the inside. So 0, 10, 20, 30. And then I can just mark my 30-degree angle there. Come to the other side, and I need a 70-degree angle attached onto the right. Looking around, I'm seeing that each one of you is doing a good job of making sure that those lines on the bottom for the 0 are actually set up in line with the component for the flat line at the bottom. And so my 70 is here. And then I can move this stuff out of the way. Now, here's one of the challenges that we face. Got that, got this. I wanted it in red. One of the parts that we have a challenge with is recognizing, whoa, I needed that back. When we try to connect this for 30-degree angle, we don't know if it's supposed to be 30 degrees with a really short side, or a medium side, or 30 degrees really, really long. because we are not told how long this side is supposed to be. Short, long, somewhere in between. So what I'm going to do is I'm just going to leave this to be pretty long. And that side length, the part that I know, that has guaranteed me that this piece is the 30-degree angle that I want. And I don't know how far along that piece I need to be. Not yet, anyway. Of course, we already had the other side marked for the 70-degree angle right along this path. Again, by itself, I wouldn't know if it's supposed to be 70 degrees short or 70 degrees long, but I can put both of them in, which gives me my 70-degree angle that I know. Now, how do you finish the triangle? Yeah, we could get rid of this little bit of slack, but the important part to notice is this is our triangle. I would like to ask, did anybody in the room get something different? Okay. I don't mean a different orientation. It could be rotated, it could be flipped, it could be upside down. But do you have something that, if you tried to transform it and move it over, would you get a different answer? Okay. Josh made a comment that one of the pieces that he had on Josh said he had a different triangle because he said he had the 70 at the top, and I'm just doing a quick sketch, not an accurate drawing or anything, the 30 here, and then the 3 inches on the bottom. Remember the name of this. We're talking about angle, side, angle. The side must be in between the two angles that you've picked. Is the 3 inches in between the two angles? No, so this is actually not a picture for angle, side, angle. This is a picture for angle, angle, side. That is actually one of the pieces that we will discuss a little bit later on in the year. It's not in this unit, it's in one of the later units. Specifically, we'll be working in a triangle unit, and we'll do it there. But this picture does not match the geometric case that we want. It's angle, angle, side, not angle, side, angle, where the side has to be in between. For everybody that kept the side in between, I'm betting maybe you have a different orientation, could be rotated, reflected, something like that, but you got the same triangle. There's a reason for that. How many ways are there to put this stuff together? There's only one way. When we were discussing uniqueness before, this was an important characteristic. Now, to create my room, I need to get rid of these tools. And I'm going to grab this stuff and slide it off to the side. Oh, man. Okay. That part I can then delete and put back on. Actually, let me just slide it over. That would make more sense. There. Now, coming back, here we go. I mentioned that there is this thought process, and I'm going to leave this picture up here. Oh, come on, that's supposed to be an eraser. Okay, angle, side, angle. When we worked with this part, what this part went to show us as an example is if we have the conditions for angle, side, angle, there was only one possible triangle that could be drawn. And we get this from the drawing. Now, since only one triangle is possible to be drawn, it leaves us open to another possibility. Suppose that we have two are the same. if we have two triangles that both fit the angle side angle criteria, we know that one of them has to be a copy of the other. And that's, of course, what each one of you has. We have a lot of copies of the one that I created up on the board. You have mine is a copy of the one that you created as well. As we've been discussing in class, if we have copies of each other, if they're copies, all the parts are going to be the same. And lastly, we did an essay in class yesterday where we were discussing if all of the pieces are the same. It's the second question from your homework. You can use motion to match them up perfectly. The logic and the process here is really, really important for you to know. As part of our standard, we have to be able to explain why angle side angle is true. Why does it give you congruence with motion? As part of our standard, we have to explain why side 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 is true and why side angle side is true. They're all the exact same answer, guys. All three of them have the same sequence of steps. Side, side, side is going to show that there's only one possible way to have that triangle. Side angle side does the same thing. There's only one way to make the drawing. Because the drawing is unique, that guarantees us, if we have two of them that fit, they're copies, which chains it with the parts matching, which chains it with the movement. All three answers are the same. The only thing that's different about it is the drawing. We will have different drawings to match the geometric cases, but the actual essay portion is the same thing over and over and over. So let's get that typed up. Now, once again, the pieces that I'm putting in are my words. You can, of course, make this fit your terminology, but we need to have this sequence of thought. So, angle side angle has only one drawing, which makes the triangle unique. So, if I have two triangles that meet the angle side angle conditions, I know one of them is a copy of the other. Again, do you see how I'm taking this logic and just writing it up into sentence format?
Yeah.
When one is a copy, and so here's my answer typed up. Later in your assignment, there is a question that asks, how does side, side, side guarantee congruence of triangles through rigid motion? It's the same thing. Later on, you have a question that says, how does side angle side guarantee congruence? It's the same thing. The only thing that's different is you change angle, side, angle into side, 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 or side, angle, side. Other than that, it's exactly the same. The only part that changes is the drawing. And so we could put in a piece, like here, angle side has only one drawing. So we could put something like this in. If we're going to talk about it being only one drawing, you should have something there that shows us there's only one drawing. This picture that I've got to the left is a part of your explanation. You should include it. Because otherwise, you're making this claim of, well, there's only one drawing possible. Well, if there's only one drawing possible, why not put down the one drawing? It's not like you're saying, oh, there's 50,000 triangles, there's 50,000 drawings, and I don't have enough time to put down 50,000 drawings, or even 5 drawings. There's only one. So show us that there's only one way to do it. Okay, so all right, so continuing onward, state the side, side, side theorem. Pretty similar to the last one. If two triangles, and my board is glitching on me, it's not letting me write correctly. Of course, it's called side, 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 so we can look at it and it tells us exactly what we need. Pair of sides 1, pair of sides 2, pair of sides 3. There we go. If we have all 3 pairs of corresponding sides congruent, so 3 pairs that match up, 3 pairs that would be the same length, that tells us the triangles will be overall congruent. So we don't need angles at all. We can just have 3 pairs of sides and not know anything about the angles and still know that we get the 3 pairs of angles for free. In terms of like an example, and once again we'll do examples like this in a lot more detail later on, but let's say that we have a triangle that's 3, 4, 5. And I could take another one over here that's 3, 4, 5. Those 2 triangles would have to be congruent, of course keeping in mind that I suck at drawing. But 3 matches 3. They're the same length, which makes them congruent. 4 matches 4. Those are congruent. 5 matches 5. Because 5 matches 5, we have all 3 pairs, side, connected to side, connected to side. Those triangles would have to be the same, giving us all the pairs of angles for free. All the pieces in yellow we get for free, saying that they're overall the same. Free angles, free! Okay, so why? Why does that work? Well, frankly, all I'm going to do it's the same thing. But instead of saying angle, side, angle, I'm going to switch it to side, side, side. Side, side, side. And there we go. It's the same thing because the logic is the same. Now, because I am a mean and spiteful person and you know how terrible I am, I want you to write it anyway. I want this to get ingrained in your head. I want you to write it over 3 times. Yes, I realize that's boring. Yes, I realize it's tedious, but it's the entire standard. Your standard is explain why this is true, so I want it in your head. Also, please notice it says side, 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 like the one I drew. This was one of the pieces that we were working on a little bit earlier. Remember a couple days ago when I asked you to draw a triangle that had sides 3 inches, 4 inches, and 5 inches? The drawing we did a couple days ago is the drawing right here. We saw that there was only one way to do it. So we started off by taking step 1 in the middle. The first thing you draw is the 4-inch piece in the middle. Then we saw that you could take the compass and draw a circle with a radius of 3 inches. Attach that to the left. Attach the circle with the radius of 5 inches to the right. And so we'd have something, and I want the color to be correct on this. So here's our 3-inch circle. Then the 5-inch circle. How many ways are there to finish this triangle?
There's 2 ways.
Here. And I like to use the dotted line to show how you'd finish the triangle. We could come up to this connection and say that's one of them. Josh, you also said, what about the one on the bottom? Because they do connect on the bottom. But I'd like to ask, is that a different triangle? Yeah, because it is the same thing reflected down, that's not 2 different triangles that work. It's the same triangle located in 2 places. Our picture has automatically created a copy for us. So this is the picture that we would wind up using. This piece with the 2 circles. Okay, the last question we had is based on side angle side. So what is the side angle side theorem? Well, it's virtually the same thing as what we had for angle side angle. If 2 triangles have 2 pairs of congruent corresponding sides, and the pair of included corresponding angles is also congruent. Then the triangles are overall congruent. Of course, after we've got that written down, state what the theorem is and how do we know? Yeah, we've got copy and paste again. So let me grab this thing and bring it down again. Yep, got to write it down again for each of the 3 times we've got it. And then the only question to finish it off, what does the drawing look like? Why is there only one? And so we're looking at side, angle, side. Well, let's take another example and say, how would you draw it? So the example will take a 3-inch side connected with a 45-degree angle, connected with a 4-inch side. Possible. I don't think this one is. It's just off my intuition is I don't think this one is. No, in fact, I'm certain it wouldn't be. Because of the 45-degree angle. You do know that 3, 4, 5 is a Pythagorean triple to create a right triangle, but it does not have a 45-degree angle, so that the 45-degree angle throws off the right triangle here. That's also something that we study a little bit in more depth later on in the year. Well, let's follow our standard pattern. Start off in the middle. Start with a 45-degree angle, and then we can connect on the left and right hand sides the pieces we need. To try to keep the video a little bit shorter, I'm not going to use the protractor to actually draw the 45-degree angle. I'm not going to use the ruler to actually measure 3 inches. We're just going to do a quick sketch. And since you're allowed to do sketches with yours also, that's fine. Here's a 45-degree angle. On the left-hand side, we need to connect something that's 3 inches long. So here's 3 inches. On the right-hand side, we have to connect something that's 4 inches long, which is there. How many ways are there to finish the triangle? How? The only thing we've got left is to connect the dots. This is why the triangle is unique. Because after we've put down all the information for side, angle, side, there's only one possible way to finish off the triangle. We saw it with side, side, side. We saw it with angle, side, angle. There's only one way to do it. That picture is part of your drawing. And thus we've finished off what we need to accomplish today. We have looked at each of the theorems for side, 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 angle, side, and angle, side, angle. You should be able to state what the theorem is. In future work, we're going to use the theorems and actually show triangles are congruent. But our focus today, explain why they work. The answer is the same for all of them. The drawing guarantees a unique triangle. So if you have two that fit the conditions, one of them is a copy of the other. As a copy, the sides, all the parts will be the same. Because the parts are the same, we could use that essay from yesterday to say, I can use movement to match them up. And we're done.